So we start with that because it's important to decipher what current reality is before you start explaining why you're doing something different. If there's no problem, why do anything different? So my role with Sirewall is I'm the operations manager and also the boss's son. My name is Krayenhoff, and I kind of grew up around this stuff, so I have a... It still shocks me. I've heard that, I don't know, over 100 times, and it still shocks me. So I'm going to be presenting Sirewall within the petals of the Living Building Challenge as a framework for the presentation. The first of which is beauty and inspiration. I'm going to go through a number of our products. I'm not going to tell you what's beautiful and what's not beautiful. I'll just let you guys decide. And some of them you will think are, and some of them you won't. So this is our most famous project. The architect did a great job of selecting the colors to blend in with the natural landscape. Each color was particularly specified in its location, and it's all the different colors on the rock and in front are all meant to blend in with that. So if you look at it from across the valley, you can't even tell that that building's there. You actually see the window at night, and that was the intended feature. This was originally intended to be done out of concrete, and then stucco. So Bruce Hayden was the architect on this project. He did an amazing job. It won the World Architectural, at the World Architectural Festival, it won the holiday category, which is the biggest honor you can get in architecture, and then it got the Governor General's Award, which is the largest honor that you can get in Canada for a building. So this is in China. We have a licensee in Shanghai, our Chinese portion of our company. He did a project where he was the architect and rammed earth builder for Vidal Sassoon. One unique part of this building, you can see that back wall is 18 inches further to the left at the top than it is at the bottom, so that's actually built on an angle. Our material, a common misconception about rammed earth is that it's weak. It will wash away in the rain and all those things that we get at the beginning of all our conversations. And we're now getting rammed earth to the strength of concrete with a fraction of the cement. Now we're going, this is a Tom Kundig designed project on Maui. He's considered one of the top architects of our generation. He plays a lot with inorganic materials. You can see in this project he uses rammed earth glass, and there's a concrete footing as his structural components. He loves our product. We've worked with him on a number of jobs. This is on Salt Spring Island. It's a project that's nestled into an arbutus grove. It's actually my favorite house we've ever built. It's not the biggest, it's not the most expensive, but it's just amazing to be in. It won 7 awards at the Georgies and Care Awards, including Best Best 2,000 to 3,000 square foot single family home in BC. This is another home on Salt Spring Island that we've designed and built. In the center there's a piano that the whole design is based around. He's a famous pianist. And the lake runs, basically the house is built at the angle of the lake, so you're optimizing your views from each room, and that's the reason for the staged design. Again, this won 6 Care Awards. So now we're looking at materials as the second petal. So Sirewall's grown, actually let me start here first. So Sirewall is composed of different inorganic material under our feet, so we don't use any of the organics. So aggregates, sands, silts, clays, rebar as our structural component, typically on a 2-foot by 2-foot grid. Polyisocyanurate is the insulation we've selected as the best option on the market. It's a rigid foam board. We use cement as our binder. We use iron oxide as a natural colorant. Cyril base admixture is something that we require in all of our projects. It's the only admixture that we require on all projects. Otherwise, we source what's locally available and look at the needs of the project. But this admixture eliminates our concern for, in this climate, things like freeze thaw, but also efflorescence and issues like that happen in masonry construction. And the last thing is pozzolans, and again, that varies depending where we are in the world. So the Cyril approach, Cyril is red list ready, one of the few products on the market that is. We utilize cradle-to-cradle approach when selecting materials. Anyone who's not familiar with cradle-to-cradle and is in the environmental conversation should be. Cradle-to-cradle looks at, it takes the conversation beyond recycling to reusing and what a truly sustainable society looks like. And it's the only, well, my favorite environmental book because it doesn't paint a bleak picture of that world. Again, silicone-based hydrophobic admixture is the only thing we use in each project. Otherwise, it's all locally sourced. We're using local materials. Manufacturing process takes place on site. So when you're filling out your sheets and it says kilometers to manufacturing, kilometers from manufacturing, it's 0. All components of our mix are integral. So this is a philosophical approach that we have where we don't like veneers. We don't like things that require maintenance. We don't like things that are going to, that the sun is going to lessen their efficiency. So basically our colors throughout the whole wall. If something happens to the surface, the color is the same. Our waterproofing is throughout the whole wall. If something happens to the surface, the waterproofing is still there. It's behind every decision we make, everything has to be integral. And Cyril is a complete wall system. This is a bit of a foreign concept in today's building society, and it takes a little while to get used to because we're used to having one material for our structural, and one material for our insulation, and one material for our vapor barrier, and one for our siding, interior, one drywall, paint. There's 7 trades in a typical stick frame building, and we're replacing those with one. And just as a philosophical approach, it's extremely important that we're constantly looking to improve our system, especially in involving such a market that's in its infancy like Cyril. So this is a project, again, we're on Maui, the Tom Kundig design. I picked it out under materials because it shows a lot of inorganic materials and a very permanent structure, again, concrete. The glass isn't in yet, but you can see the thickness of the rammed earth and the steel on top. Oh, actually, one more thing on that before I move on. The client is on the left, and at the beginning of each project, we suggest you do a test wall so you get the right color. If we don't do that, we find we get a paint chip problems that when you blow it up, it's too vibrant. So the next petal is site. Site is something that we haven't got to play a lot with on a large commercial scale. What we have played with is extending our walls from under the building envelope out into landscape walls. We've done that on almost every house we've built. But the potential for rural applications are to control erosion of site. When you're building with our material, an opportunity is to choose sites that maximize orientation and placement for solar gain, light, heat absorption, or cooling, depending on what climate you're in. And integration of site and rainwater harvesting in our agriculture, excuse me. So again, due to our infancy, we haven't had a lot of urban applications, but there's a lot of potential there, especially from sound management. Our material is extremely effective at either keeping sounds in or keeping them out, depending on what the goal is. In a factory, it would be to keep the sounds in so you're not polluting noise. And if you're beside an airport, it would be more important to keep the sounds out. Another opportunity is to incorporate agriculture into an urban center, as you see on the right. You can't see it that clearly. but these are all concrete upstand walls. And if those were done out of rammed earth, it would be as if the plants are growing. You get your structural component, and the plants are growing out of the earth. It's very appealing to a lot of architects. We hear that on a lot of designs. So this is a project that's been built to LEED Platinum and LBC standards. We believe we're waiting back for the allotted time to hear if we get the certifications. But it's in China. It's 3 to 4 hours north of Shanghai, and it's in what they would consider a forest. Not quite what we consider a forest. And it's a retreat to get out of Shanghai and out of the smog and that air that they have to breathe every day. For energy. So here's a typical 24-inch firewall. If you look on the interior of the building, which is the side with the electrical plug, that would, in a 24-inch wall assembly, that section would be 12 inches of rammed earth. The green in the middle would be 4 inches of insulation, and then 8 inches of rammed earth on the exterior. Our rebar's typically on a 2 foot by 2 foot grid, both vertically and horizontally. The electrical box, which we use a typical steel concrete gang box, would be in plane with the face of the rammed earth. So the conduit runs inside the wall and directly up or directly down, and then along a chase at the top or the bottom of the wall. So it's getting out of your space from an electromagnetic field perspective and home running back to the electrical panel. So there's a few things where things are either misrepresented or misunderstood in typical construction. One is that we build R20 walls. We don't actually build R20 walls, we put R20 insulation into our walls. Then there's the thermal bridging from the studs. I'm referring to the picture on the right here. So there's the thermal bridging of the studs around, in this case, the window it's showing you. And the best possible result of a R20 wall is R14. In practice, it ends up being closer to R11. So you're getting basically half the promised R value. If you look at our window detail on the left, this is a typical flanged window for us. You have the rammed earth on either side, the insulation plane extending past the end of the wall. You have your nailers, which are embedded into the wall. And then the flange, your insulation runs right up to the window flange. So there's no thermal bridge, or as minimal as possible. There's always something, but there's no conceivable thermal bridge between the wall and the window. My father, Mir, is an energy systems technologist by trade, so this is the stuff that really lights him up, that he loves. So we have all these details for windows and different windows and doors that let us know which ones you want. Another kind of conversation that we're very young in North America is R value. When we say R value, we actually mean static R value in North America. And static R value doesn't take into account thermal mass. It's basically just adding up the R value of all the materials, and that's your static R value. There's dynamic R values are more difficult to calculate. The reason being you don't know what orientation a certain building will have. You don't know how much windows, how much light, some heat will be coming through those windows. So it's more challenging, but thanks to Dr. Jan Kosny's research at the Oak Ridge National Laboratory, where he researches different wall systems, so mass, insulation mass versus insulation mass versus insulation mass insulation. He might not even know about us for all I know, but his research is perfect for us. So with our wall system, thanks to his research, we know that our mass insulation, mass wall system in our thicknesses will have an impact of 1.5 to 2.25 times the static R value, depending on, like we talked about, orientation and design and things like that. So basically you take R33, multiply it by 1.5 or 2.25, and you get R50 to R74 as your performance R value. It's a much more telling statistic. Sarwell is ideally suited as a result of that to projects. Excuse me. As a result, Sarwell is ideally suited to net zero projects or clients who operate from the philosophy that an ounce of prevention is worth a pound of cure. That philosophy, I've applied it here to energy, but it can be applied to any value you have in your health, whether it's in your house, whether it's health or structural or whatever it may be. And we have, our partner company has experience building off-grid houses, and we'll get to one of those a little bit later. So this is a house, BCIT came and wanted to do some research on us because we're a different technology. So we have a good relationship with BCIT, which is, again, awesome for us. And where there was a house for sale on Salt Spring Island, and they put a data logger on the interior and out tip and exterior of the building at the same point to measure the humidity and temperature. And what it came back with is outside, the relative humidity ranged from, you can't really see them at this point, but it ranged from 55 to over 90%. And inside it's constant between about 50 and 58. So it's the blue line on each of those graphs. The red line, what that means, like Keenan said, mold can't grow at under 65%. So we've basically eliminated mold from houses with this. There's still the possibility of a pipe blowing and being contained in an area or something like that. But with the thermal and humidity flywheel of rammed earth, mold can't get, if it can't get over 65, mold can't grow. And the last one, the heat, the temperature is, on the inside is ranging between 15 and 18 degrees. And outside, this was done in the fall, and it ranges between, looks like, 3 and 12 degrees. We'll say an average of 8 Celsius and an average of 17 inside. So you're getting 9 degrees of free heat. This is an unheated, unoccupied space. This project, we're running short of time, so I won't read the whole quote. But basically, the power went out for 4.5 days. It was 22 degrees Celsius. This is a north-facing house, so it doesn't get much solar gain in the middle of winter. Outside temperatures were 0 to 5 to -5 over those 4 days. And indoor started at 22 degrees Celsius, and after 4.5 days, it went down to 14 degrees Celsius. So we got an awesome email from the client where he was just absolutely thrilled and saying that his new house that he was building he got his bill from BC Hydro, and it cost him less to heat his house that he was living in than his cottage on the same property that was unoccupied. So water, this is a little bit theoretical, and I want to focus on the next part more, so I'm just going to go past this. This is Van Dusen Gardens. I think everyone's probably aware of this project. It's been in the news a lot. I know Ledcor is. And it was a pleasure to be involved in this project. You can see the rammed earth walls on each side. Again, it's going for Living Building Challenge and LEED Platinum. The walls are intended to look like they're growing out of the ground. So a very cool project, a lot of innovation. Indoor quality. So, as you've noticed by this point, we're pretty passionate about health. This is the healthiest home we've ever built. There's no plywood, there's no fiber boards, there's no, what else is there? There's no drywall. Try to find a house without drywall and without fiber boards. So the paint that you can see in the top left there, that was imported from Germany because there was nothing acceptable in the market here. Another thing that we learned from Katerina Gustavs, who this is actually how we developed our relationship with her, is the electromagnetic field, or sort of the microwave pollution On this, the allowable microwave pollution limits in North America and Great Britain is 200 milligauss. And how they measure that is when your body starts to heat up, it starts to cook. In most of the rest of the world, it's below 8 milligauss. So we're very naive in that conversation. And these people had a perfect building site, and they moved and blasted and did a lot of the finishing themselves to move to an area that they were comfortable raising their family in. So I have a ton of respect for this family. This is a building built for someone who had multiple chemical sensitivities, and basically their body was rejecting all the buildings in the world that they went into. So this was a retreat that her husband built for her and hired us to do the rammed earth, and an extremely simple design because they were tight on money. This is Randy Bachman's house. It was featured on David Suzuki. When they moved in, again, health was the most important thing to them. Their daughter had asthma and she was having to go to the hospital all the time. She couldn't breathe. And within a year of moving into this house, she threw away her puffer permanently. This is a house that Keenan got to live in when he was working for us on Salt Spring Island. And Keenan also always carried a puffer around with him. And after living in this house for 9 months, he's since moved back to a traditional house in Vancouver, developing the market there and expanding into a worldwide company. But after 9 months of living in this house, Keenan also hasn't bought a puffer since. So that's then my slideshow. I'm extremely passionate about the health and the lives that we've impacted so far, and I'm really excited about the lives we can impact as we grow as a company.